Alright, the next problem we're going to work on now is f of x equals x to the 6th minus 6x to the 4th minus 31x squared plus 36.
Alright, first thing we're going to do, list out our p's and q's. Luckily for me, this is the same p's and q's as the last time. So I know my p's are going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, plus or minus 9, plus or minus 12, plus or minus 18, and plus or minus 36. Our q's, again, luckily have a 1 here, so this is just going to be plus or minus 1. The last time it worked out really, really well that I tried the 1s and 2s and it worked. I'm going to try this again, although I know that it's not going to work this time because if it worked on the last one and these equations are different, it's not going to work this time too. But we're going to see. So my coefficients are going to be 1 for my x to the 6th term. I don't have an x to a 5th, so 0. Negative 6 to x to the 4th. X to the 3rd is 0. Negative 31 for x squared. I don't have a linear term. And 36 for my constant. I always like starting with 1 and positive negative 1. So let's start with 1 and see if this works. If I bring this down, 1 times 1 is 1. Add those together, I get 1. 1 times 1 is 1. Add those together, I get negative 5. 1 times negative 5 is going to be negative 5. Add those together, I get negative 5. The reason I like doing 1 is because it's really easy multiplication. 1 times negative 5 is negative 5. When I add these together, I get negative 36. 1 times negative 36 is negative 36, and I can already tell I'm going to like the first one. Add these together, I get negative 36. 1 times negative 36 is negative 36, and when I add those, I get 0. So 1 definitely worked that time. So I'm going to cross off here. Let's try negative 1 on our next term. So again, I'm going to bring this down. Negative 1 times 1 is negative 1. Negative 1, or 1 plus negative 1 is 0. Negative 1 times 0 is 0. Negative 5 plus 0 is negative 5. Negative 1 times negative 5 is positive 5. Add those together, I get 0. Negative 1 times 0 is 0. Negative 36 plus 0 is negative 36. Add these together, and I get positive 36. Hey, look, that one worked too. So negative 1 is also going to be one of my roots. Alright, so 2 worked last time. Let's try 2 again this time. Alright, so first thing I'm going to do is I'm going to bring this down. Alright, 2 times 1 is 2. When I add these together, I get 2. 2 times 2 is 4. Add those together, I get negative 1. 2 times negative 1 is negative 2. Add those together, I get negative 2. 2 times negative 2 is negative 4. When I add those together, I get negative 40. This does not have a 0 for a remainder, so I know 2 is not going to work. Good thing is we use a pencil in math class, so I'm going to erase this, erase my work, and I'm going to start over. So I'm going to go over here to 2, and I'm going to go ahead and cross it off, because I know I tried positive 2 and it didn't work. I'm not going to try negative 2 because I don't think negative 2 is going to work here, just because negative 2 worked on the last one. So I'm going to jump ahead, and I'm going to go to 3. Let's see if 3 works. So I bring that down. 3 times 1 is 3. Add those together, I get 3. 3 times 3 is 9. Add those together, I get 4. 3 times 4 is 12. Add those together, I get 12. 3 times 12 is 36. Hey, look at that. 3 ended up working. Now again, there's my remainder of 0. I have a constant, linear, quadratic, and cubic. So I need to get one more before I can break it down to a cubic here. So 3 worked. Let's try negative 3. Hopefully negative 3 will work. But we'll see. Bring down the 1 here. Negative 3 times 1 is negative 3. Add those together, I get 0. Negative 3 times 0 is 0. Add those together, 4. Negative 3 times 4 is negative 12. Look at that. And I get 0. So my roots are going to be 1, negative 1, 3, and negative 3. And then I'm going to be left with this quadratic here. Let's go ahead and write down x minus 1, x plus 1, x minus 3, x plus 3. And I'm also going to have the root here if I have a constant of 4, no linear term, and 1 as a cubic, so I'm going to have x squared plus 4 is going to be my cubic, x squared plus 4. To figure out my solutions, obviously it's going to be my roots. So I'm going to take a shortcut from last time. I know it's going to be plus or minus 1, plus or minus 3. And just in case if you didn't catch my skipping of a step last time, if I have x squared plus 4 equals 0, I'm going to subtract 4 from both sides. This is stuff you did in Algebra 1. So x squared equals negative 4. When I take the square root, this is something we did earlier, I'm going to have x equals 2i, or plus or minus 2i, because remember we can't have a negative underneath the square root. So my other solution is going to be here, plus or minus 2i. And here we are done. That's my final answer.
Alright, this last problem that Griffin's going to show you is number 5 from this tiny little worksheet. Remember, Mr. Lazarski likes to save paper. So, here's the problem. Let's go.
Alright, I'm going to flat out tell you, I'm going to fly through this one. This one's going to be a big nasty. I would highly recommend trying this problem, yeah, of course, but you're not going to see anything like this on the test, something this difficult. You're going to see more stuff like the first few problems on this homework sheet, or better yet, you're going to see something like we've done on the board, something that has a bunch of P's and Q's but doesn't have fractions. So know ahead of time that I already know the answer to this. I already know what the roots are, so I'm automatically going to go to the correct answer. Just try to follow along. First thing is P's and Q's. My P is going to be negative 12, so I'm going to want my roots of negative 12. That's going to be plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 4, plus or minus 6, and plus or minus 12. My Q's, and this is what makes things difficult, my Q's are going to be plus or minus 1, plus or minus 3, or plus or minus 9. So in this case, I can end up having something other than whole numbers. I can have fractions, and indeed I am going to have fractions. So let's go ahead and start our synthetic division. So I know that my things will look like this. I have no x to the fourth, negative 94 for third, 27, linear is 40, and then negative 12. I'm going to go ahead and jump to, let's do 2/3 first. I know 2/3 works, so let's do 2/3. And again, I get 2/3 from having P for my 2 and my Q being 3. So positive 2, positive 3 for doing my 2/3. When I do this, bring it down, of course. 2/3 times 9 is going to be 6. Add those together. 2/3 times 6 is going to be 4. So that's going to be negative 90. 2/3 times negative 90 is negative 60. That's going to end up being 33. 2/3 negative 33. Multiply that together. I'm going to get negative. Is that 22? I think it is. It is. When I add those together, I'm going to get 18. Then when I multiply 2/3 by 18, I'm going to get 12. And I get 2/3 being one of my roots. The next one I'm going to try, I know that 3 is going to be a root. The reason I know that 3 is going to be a root because I've already done my homework. When I bring it down, 3 times 9 is 27. When I add that, I'm going to get 33. 3 times 33 is going to be 99. Add those, negative 9. 3 times
positive
negative
9.
You're right, positive 9. 3 times 9 is 27. This is where I'm going to start getting rid of my negatives. So this is going to be negative 6. That gives me negative 18, so that's going to be 0. And lastly, my last root that I'm going to have, because this is still a cubic, is going to be negative 2/3. Here we go. Break down my 9. Negative 2/3 times 9 is going to be negative 6. When I add this, I'm going to get 27. Negative 2/3 times 27 is going to be negative 18. When I add these, I'm going to get negative 9. Negative 2/3 times negative 9 is going to be, is it 6? Yes, 6, so I get 0. So it does indeed work. And that's my remainder from the previous problem, not a 10. So I have a 0 for remainder. So now I have my 3 roots and I have a quadratic. So let's pull that to the side. So this is going to be x minus 2/3, x minus 3, x plus 2/3, and 9x squared plus 27x minus 9. And all that's going to equal 0. I already know that part of my solution is going to be plus or minus 2/3 and 3, but I need to figure out what the solution is going to be for that. I always go to the quadratic equation, so let's do the quadratic equation.
Minus 4.
Well, I was going to go ahead and jump in. It's minus 4ac, but since I have a negative and a negative, that's going to be a positive. I'm going to end up adding those together. All over 2a, so 2a is going to be 18. This is going to be 1053, I believe is what we got. So I have negative 27 plus or minus the square root of 1053 over 18. 1053, Gruget found out to be was the same thing as 9 plus or minus, or 9 square root of 13 all over 18. So when I reduce this, I'm going to go ahead, I'm going to reduce it up here. It's going to be negative 3 plus or minus the square root of 13 all over 2. And that right there is going to be my answer. Again, this is going to be a lot harder than what you're going to see on the test. You guys should be able to do this, your honors kids. But do this problem and then go back and look at the previous 2 we did and see if you have any questions.